Hi, and welcome to this video on question 14 of the 2019 Paper 2 Junior Share High Level. As always, if you want the set of notes I'm working off, just send me an email at shanetroy@gmail.com. That email address should be in the description below. So I suggest pausing this, having a go. But question 14 here, assuming you're back, says a cylinder has a radius of r centimeters. Okay, so the radius of that is from here to the outside is r. And has a height of 10. So that height there is 10. This cylinder is melted down, so this yolk is melted down and recast into a cone. This cone also has a radius of r, so it's the same radius, okay, so using the same variable. That's r, from here to here, and has a height of h. So that height there, okay, that's going to be h. Now sometimes you might be asked to find the slant height there if you think that's a right angle triangle, but let's see what's happening. So 10% of the volume of the cylinder, so this is the cylinder, so 10% of that is lost during the process. So whatever volume of this, okay, it's going to be, take away 10% of that, okay? Or another way of putting that is, it's going to be 90% of the original volume. So 90% of the volume of the cylinder, okay, is equal to 100%, or basically the volume of the cone. I should call that V. Okay, so now I've done that one in notes, so we're looking to actually at the end of it all work out the percentage increase of the height of the cylinder when it was made into a cone. So how much has the height increased? Okay, so let's flick on the answer here. So I've said that already here. The 100% take away 10% gives 9%. Now, 9% is the same thing as 90 over 100%, which is the same thing as 0.9. So 0.9 times the volume of the cylinder is going to be equal to the volume of the cone. So right there, you have at least the attempt there, those statements. You show you know what's happening. Then we're going to swap in the volume of the cylinder formula. Now, that I have set, the mass table is open, so if you're ever doing anything to do with volume, okay, just go to the sections on area volume. Okay, you see there you have your volume of a cylinder and you have your volume of a cone. So even just writing those two things out, if you can use them, okay, you're going to be definitely guaranteed probably the next stage of marks. So I'm going 0.9 times that formula. Okay, now I'm using big H here, okay, to represent that height. I'm using little in the whatever data I have, so it's 0.9 times pi r squared times 10. Remember they're all multiplied. Is equivalent to a third times pi times r squared times h. There's an awful lot of unknowns here, okay, so you can you can seem like you're going wrong until you realize that if something's common to both sides, they're cancelled. You don't need to bring things across, they will cancel. And then the r squared here cancels the r squared here. So you're left with just 0.9 times 10 is equal to a third times h. Now I've just taken a little bit of liberty here for space, but basically 0.9 times 10 is 9. Brought this 3 over, it becomes multiplied. So 9 times 3 is 27, is equal to our height. So what's the difference between the two heights? Well, we know this is 10, we know this is 27. The difference is 17. And that feeds into our percentage increase formula, which is the difference over the actual, okay, yeah, I remember it, all multiplied by 100. So put it through the calculator, you're going to get 1.7 by 100 is 170. And that's percent. And it's bigger, you'd expect it to be an increase, so you expect it to be bigger than the original, bigger than 100%. And that's it. Okay, so that's question 14. And thank you, and see you in the next paper.